we're going to look back at sections 2 and 3 and talk more about arithmetic and geometric patterns. But today we're going to talk about series, which is where we're adding the terms. So in a sequence, we're just listing the terms. In a series, we want to add the terms and find out what they all add up to. For an arithmetic series, we have a formula again, and once again, it does not need to be memorized. Okay? It says in words, basically what's happening here is it's taking the average of the first and the last term and multiplying by the number of terms that there are. There's a story in math history about a precocious little boy named Gauss, who was, I think, about 6 when this happened. But it was a long time ago, back when the teachers were teaching every child in the same room. So you have little kids, older kids, and trying to keep everybody busy. And she just couldn't keep this kid busy. Like, he just kept doing everything way too fast, and he wanted to learn. So he just kept asking a lot more. And she finally just got so frustrated with him. And she's like, I need to be able to work with other people. I want you to go to your desk and add up all the numbers from 1 to 100. And figured, okay, this is going to take this kid a while. They don't have calculators, right? So it's going to take a while. About a minute later, he walks up to her desk and hands her the answer because he figured out this pattern that he could add together the first number, the last number, divide by 2, and multiply by how many numbers. So I don't like history, but I love that story, just of a frustrating child. So he figured out that he could just add up 1 and 100, divide by 2, and multiply by 100, and that would give him the answer to the question that she asked. So that's the pattern that we're going to be using here. So I'll rewrite it. Part A asks us to find the sum of the first 30 terms. So for part A, n is 30. Okay, the number of terms that we're doing is n. So we are looking for s sub 30. So according to the formula, n is 30. A sub 1 is what? 4. Okay, A sub 1 means first term. So the first term is 4. A sub n, in this case, would be the 30th term. But we don't know what the 30th term is. So we could just continue the pattern on out and figure out what the 30th term is. But if I asked you for the 300th term, that seems pretty annoying to have to do that. So what we're going to do, use the formula from a couple of days ago, which was a sub n equals a sub 1 plus n minus 1 times d. That was our arithmetic sequence formula from a couple of lessons ago. And it does not need to be memorized. So we want to find out a rule for this series so that we can find out what that 30th term is. So a sub 1 is 4. And minus 1 times, what is d for this sequence? 3. We're adding 3 each time. So we can distribute that 3 and combine like terms to find our rule is 3n plus 1. So that part of the problem is very similar to what we did 2 days ago, using the old formula from a couple of lessons ago to come up with a rule for a sequence. We want to use that rule to now say what is the 30th term. So we plug a 30 in for n, and we get that our 30th term is 91. So we're going to plug a 91 in there. And divide by 2. Then we our calculator to work out the arithmetic, being careful with order of operations and parentheses, and get 1,425. Right? Questions on that part?
Wait, what's that 175 for?
That's part B. We haven't gotten to part B yet with the 175. Any questions on part A? So for part B, the question is, how many terms do I have to add up to get 175? It's going to be less than 30, because adding up 30 terms gave me 1,425. So it should be less than 30, but I don't know how many. So could just start adding up the terms that were given, and then continue finding more terms and continue adding them up until you get to 175, and then say, okay, how many things did I add up? Okay, it's going to be less than 30, so it's not going to be terrible. So that's a possibility. That's one way to do it. But we can do it algebraically as well. So we're going to use that formula, our new formula from today, and say our sum is 175. We don't know what n is, because we don't know how many terms we're trying to add up here. A sub 1 is our first term, which is 4. A sub n is the last term, but the problem is we don't know what the last term is because we don't know how many terms we're adding. But we found a rule for a sub n, so we're going to plug in that rule. So since we don't know how many terms we have, we don't know what our last term is. So instead of being able to plug in a number there, we're just going to plug in our rule there. Questions so far on why something was plugged in a particular spot? Okay, to solve, I want to get rid of the fraction, so I'm going to multiply both sides by 2. So it gives me 350 equals n times, and on the top I'm going to combine the like terms to make it 3n plus 4. No, sorry, plus 5. I didn't actually combine them. Then I'm going to distribute. This turned into a quadratic equation. So to solve a quadratic equation, I want everything on one side. So I'm going to subtract that 350. This is factorable because n has to be a whole number. N cannot have decimals because n is how many terms. So we can't go like 12 3/4 terms. That doesn't work. You have to be going a whole number of terms. So it is factorable. It's not particularly easy to factor since it has that 3 in front of the n squared, and 350 is such a big number. So you could try to factor it, or I would probably just go with my quadratic formula. So then plugging values into the quadratic formula, I get -5 plus or minus square root of 5 squared minus 4 times 3 times -350 all over 2 times 3. If you have like a quadratic formula program or something on your calculator, you can.
Not for the summation.
Oh, no.
Wait. Yeah.
So then I can evaluate the whole square root as one piece. So I'm going to do the square root and all the stuff underneath it. Which gives 65. And again, you should always be getting whole numbers on these because we can't have a decimal place term. We get 2 answers when we do a quadratic formula because of the plus and minus, but we only want the positive answer because negative numbers of terms don't make sense. So I'm just going to do a -5 plus 65, which is 60 over 6, or 10. You could do guess and check and add up 10 terms and you would get there, or you can go through the algebraic process. Now 10 terms isn't bad, so guess and check probably would have been faster, but if it was like, 100 terms, 50 terms, something like that, And it's likely you might make a mistake somewhere within typing in all those values. All right. Questions? Yes.
So if you just, instead of doing the quadratic equation, you just like factored it out, find once you have the two.
Yep, if you solve by factoring, did you factor it out?
Yeah.
What is it?
I didn't do it for that problem.
Oh. You would just solve each of them equal to 0, but you only want the positive solution.
Oh, right.
How do we get 65 there?
I typed in the square root and Right. Other questions? All right, let's try another one like this. The good news is this is the hardest one. So a lot of times the problems build as we go. In this lesson, this is actually as bad as it gets. It gets easier from here. So we're going to start with our formula. Part A wants us to find the sum of the first 25 terms. So that means for part A, n is 25. So we're going to find s sub 25. N is 25. A sub 1 is 20. A sub n is the 25th term, but we don't know what the 25th term is. So this is where we have to take our little side note and do the formula from a couple of lessons ago. So a sub n, a sub 1, which you just said was 20, plus n minus 1 times d. What is d for this sequence? Negative 2 is what we're adding each time. So we distribute that in and combine like terms. So our 25th term would be what we get when we plug in 25. Which is negative 28. We calculate that carefully with parentheses in order of operations to get negative 100. So if I add up the first 25 terms of this thing, it's going to be equal to negative 100. So one way to do it would be just to list out all the 25 and add them up. But that's kind of a lot of numbers to add up. Questions?
How did you get the 28?
I used the formula from a couple of days ago to come up with a rule for the sequence. And then I plugged 25 into that rule, and that gave me the negative 28. Part B asks us to find how many terms we have to add up to get to negative 760. It's going to be more than 25. Because if it takes 25 to get to negative 100, I need to pass by that, so it's going to take more than 25 terms. So this is a case where guess and check would probably not be a good option, because we don't know how many more. I mean, it could take a lot more. We don't know how many terms it's going to take to get to that negative 760. So we're going to say negative 760 is equal to, we don't know n, a sub 1 is 20, a sub n is our rule that we came up with when we did that little side note. So we plug in that rule for a sub n. and divide by 2. Questions on where something came from? Then I'm going to multiply both sides by 2 to get rid of that fraction. And combine like terms, so I get negative 2n plus 42. Yes?
Why isn't the n on the right side of the equal sign not a 2n?
There's no 2 n's in the formula. I'm just applying the formula, and in the formula it's just an n.
Well, like when you multiply the whole equation by 2.
I multiplied both sides by 2. So I don't have to multiply the n by 2 as well, because that's on that same side.
I still struggle with the how you get negative 2 and plus 22 from like even less than 1.
Okay.
How did you find those?
Yep, to come up with the formula for a sub n, I used a couple pages back in your packet, so you can look that up. You don't have to memorize it. And that formula tells us to plug in a sub 1, which is 20, plus n minus 1 times d, and the common difference is what we're adding, which is negative 2. And then I distributed through and cleaned up that rule to get our a sub n. Okay, so now I'm going to distribute the n. And it will become quadratic. So I want to move everything to the same side. This one has a negative 2n squared. I like to move everything to where the n squared is positive. So I'm going to move everything over to the left side on this one. So I'm going to add 2n squared and subtract 42n with that negative 1520. Move everything to the left so that I get a positive value for the n squared. You can go either way. I just like to have the positive n squared. What do you notice about all the numbers? They're all divisible by 2. So we're going to divide them by 2 because that gives us smaller numbers to work with. This one is factorable. 760, there must be something that multiplies to 760 that adds to negative 21. Okay, they have to be factorable because they have to be whole numbered answers. They can't be decimal answers. So you could solve this by factoring if you can come up with what multiplies that adds to negative 21, or you can use your quadratic formula. And I don't care which way you do it, or if you do have a quadratic formula program on your calculator, you could put the values in there as well. This is 21 plus or minus square root of negative 21 squared minus 4 times 1 times negative 760 all over 2 times 1. Be careful when you type in this stuff under the square root, particularly with that negative 21 squared. Either make sure that that negative 21 is in parentheses or don't even type the negative, because when you square a negative, it needs to become positive. So that whole square rooted portion should give us 59. And you should always get a whole number for that. If you get an ugly decimal, something went wrong. Then I'm only going to do the addition, because if I do the subtraction, I would get a negative, and that doesn't make sense. So I only want the positive answer. So I do 59 plus 21, which is 80 over 2, which is 40. So that means I would need to add up 40 terms to get to a total of negative 760.
Do we have to divide by 2 right there? So like when you have 2n squared plus 42n, do we have to divide by 2?
You do not have to divide out by 2 before applying the quadratic formula. You should still get the same answer. It's just that the numbers are bigger and messier to work with, but it should result in the same answer.
So for the two numbers, in like for the numbers that you got from the quadratic equation on the top of the fraction,
Mm-hmm.
the number on the right, will that ever be bigger than the number on the left?
Yes, you just want to choose to either add or subtract so that you always end up with a positive answer.
Okay. Or I think I was going to ask smaller than the number on the left.
Yep, it could be either. So you just want to make sure you add or subtract so you get a positive. All right. All right, so this one asks us to find the sum of this series. So we're going to use our sum formula. What is n in this question? 34. If we start at 1, the top number is our n value. We will talk in our very last example about what happens when we don't start at 1. But if you start at 1, which is what's going to happen most of the time, then the top. So we are looking for the sum of the first 34 terms. So n is 34. How do I find a sub 1? Doing the formula and plugging in 1. Plug in the bottom. Whatever's on the bottom, which in most of them will happen to be 1. So we plug in 1, and that gives us 9 for a sub 1. How do I find a sub n? The rule and plug in 34. Which gives 273. Okay. By plugging 34 into the rule that's inside of that sigma. So 1 plus 8 times 34 is 273. Okay. So n is the number on the top. We find a sub 1 by plugging in the bottom. Find a sub n by plugging in the top. And then we plug that into the calculator. Again, careful with parentheses and order of operations.
Mrs. Strayer?
Yes.
Can you send Thomas Blackport down to the office?
Yep.
Thank you.
And we get 4,794. Okay. Questions? All right, so this one I'm going to run through pretty fast so we can make sure that we have time to get to the other types of questions, but I will still run through it here if it lets me. It's not letting me. Okay. So S sub n equals n a sub 1 a sub n over 2. What's n? 22. The number on the top gives us our n. A sub 1 is what we get when we plug in the bottom. So 6 minus 3/4 times 1 is 5.25. Then a sub n is what we get when we plug in the top. So 6 minus 3/4 times 22, which is negative 10.5. Over 2. Let me plug that in. Again, careful with parentheses and order of operations to get negative 57.75. Right. Next is geometric. Good news is geometric is easier than arithmetic. So once again, you have a formula that you do not need to memorize. This is the in terms of geometric. So in our first question, part A tells us that we want to find the sum of the first 10 terms. So we're looking for S sub 10. What is A sub 1? 1. A sub 1 means first term. Then 1 minus R. What is R? The ratio, which in this question is 5. That's what we're multiplying. We move through those terms by 5 each time. N is 10. And R is still 5. Okay, so that ratio is what we're multiplying by. So what do we multiply to get from 1 to 5 to 25? Multiplying by 5 there. So then we know everything we need to know, so we can plug it in the calculator, again, being very careful with parentheses for order of operations. We should get 2,441,406. So I said when we were going over the homework that since geometric series are exponential, we're multiplying by something over and over and over, we should not be surprised if they get really big really fast. So 10 terms is not a lot of terms. These things are going to get really big really fast. Okay. Yes?
I was still on the last one, and you know when you got 5.25 minus 10.25?
Mm-hmm.
I checked in the calculator twice and I got 10.5.
It was 10.5.
It wasn't 10.25?
No, it's 10.5. B, we want to add up to 3,906. We know it's going to take less than 10 terms because 10 terms all the way got us past 2 million. So we know it's going to be less than 10. So you could totally guess and check this and just add up. There's the first 5 terms. Keep on adding terms until you get to 3,906. And that's okay with me if that's the way you want to do it. But I'm going to show you the algebraic way as well. So our sum is 3,906. A sub 1 is 1. Minus R is 5. And what we don't know is N. No quadratic equations on this one, so this turns out a lot nicer. Geometrics are easier. I'm going to start by saying that this bottom is equal to negative 4 and multiply both sides by negative 4. That gets rid of my fraction. So that gives me negative 4 equals 1 minus 5 to the n. I'm going to subtract 1 from each side. Gives negative 15,625 equals negative 5 to the n. Double negatives, cancel them out, and then guess and check it. So 5 to the first, 5 to the second, 5 to the third, 5 to the fourth, 5 to the fifth, 5 to the sixth. What is it? And we just keep on trying until we get 5 to something to be 15,625. And that is 5 to the sixth. So adding up 6 terms of this series would give us 3,906. That's not very many terms, so it probably would have been faster to guess and check on this one, which is fine if that's the way that you want to do it. Okay. Questions?
So just guess and check then?
guess and check at the end there. Yeah, 5 to what power is 15,625? Same types of questions here. Write out the formula again. For part A, we're finding the sum of the first 10 terms. A sub 1 is what? 4. R is what? A half. We're multiplying by 1/2 each time. The power of n is 10, since we're looking for 10 terms. Again, careful with your calculator. If you want to plug in a half, put parentheses around it. If you want to type in 0.5, that's fine, but you can't do that if it's like a third. Okay, so anytime you type in a fraction, make sure you put parentheses around that fraction. So 1 minus a half in parentheses, or 0.5 to the 10th. Do not round off as you move through the steps in this question. Just keep letting your calculator build on the previous answer. So I'm then going to divide that by a half and multiply that by 4. If you round off as you go through the problem, it will create error that will cause your final answer to be wrong. So adding up 10 terms gives me 7.992. I want to know how many terms I need to add up to get 31/4. Okay, so I'm going to say 31/4 is equal to, a sub 1 is 4, 1 minus a half to the n, because I don't know how many terms, over 1 minus a half. The first thing I'm going to do is divide both sides by 4 to get rid of that 4 that's in the front. That gives 31 out of 16. 1 minus 1/2 to the n over, and then that denominator, 1 minus a half, is just a half. So I'm going to do that arithmetic there. Then I want to get rid of that half that's on the bottom of the fraction. I'm going to do that by multiplying both sides by a half. Whenever you want to cancel the denominator, you just multiply by it. So that gives 31 over 32 half to the n. Subtract 1 from both sides. Gives negative 1 out of 32. Equals negative 1/2 to the n. Cancel the negatives and guess and check. 2 to what power is 32? You might actually already know that one because we've worked with 2's a lot, but maybe not, so you just check. So 2 to what power is 32? 2 to the 5th. So adding up 5 terms would give us 31 over 4. Okay. I know these first types of problems are long. I know they are. I know they're time-consuming, long. There's lots of steps involved in them. You don't have very many on your homework then because of that. And remember, guess and check is an option as well if you want to stay away from all of the algebra. The last questions, once again, are much quicker. What is n in this one? 10. So we're looking for the sum of the first 10 terms. A sub 1, how do I find that? Plug in the bottom. So 6 times 2 to the 1 minus 1 gives me times 2 to the 0, or 6. How do I know what r is? What does r mean? It's the rate or the ratio. It's what we're multiplying by each time. So which part of this formula gives us our rate or ratio? The 2. It's what's taking on the exponent, because that 2 is what's being multiplied by each time. An exponent does is multiplies by that same thing over and over and over. So whatever has the exponent is going to be your r. So that base of the exponent is always r to the power of n, which is 10 for this question. And 1 minus 2 on the bottom. Again, just be really careful with your calculator in order of operations. It's to the 10th. Sorry, it's a 10. It just isn't a very clear 10. So I get 6138. Right. Last one. I told you in our last example I would tell you what happens when we don't start at 1. Right? It's not that much harder. It's just something you need to watch for. Okay? It's not really any harder. It's just something you need to watch for. When we do not start at 1, that means the first thing I'm plugging in is 0. And then plugging in on up to 6. So plugging in 0, 1, 2, 3, 4, 5, 6. How many terms am I working with? 7. So that means n is really 7 on this one, because that's how many terms I'm working with. So if you start at 1, n is the top number. If you're starting somewhere else, you need to think about how many terms are you working with. So 0, 1, 2, 3, 4, 5, 6 gives me 7 terms I'm working with. So n is 7 for this question. Using the same formula. So we're looking for the sum of 7 terms. A sub 1 is not always what you get when you plug in 1. It's what you get when you plug in the beginning. So plug in a 0. Always just plug in that bottom number. So plug in the 0 gives me 4. What's our ratio here? 3 over 2. It's always the base of the exponent. And then we're raising that to the power of n. Careful with your parentheses, and don't round off as you work through the problem. You get 128.6875. Question?
How did you get the 7 again?
Noticing that I'm starting at 0, that means I would start by plugging in a 0 and then keep on plugging in until I plug in 6. So plugging in 0, 1, 2, 3, 4, 5, 6 means I'm really plugging in 7 things. So n is the number of terms that we're working with. So that 0 gives us 1 extra term. Okay. Your homework is from 11.2 and 11.3, so be careful with what numbers